This section belongs to IMU CET Mathematics. I am Dr. K. Anandi from PSM College of Engineering and Technology, Tirunelveli. This section belongs to IMU CET Mathematics. First, we go through the syllabus. What are the syllabus in our IMU CET Mathematics? Functions, limit, continuity and differentiability, inverse trigonometric functions, determinants and matrices, differentiation and applications of derivatives, indefinite integral and definite integral, differentiation equations, vector algebra, 3D geometry, linear programming and probability. These are the sections which are involved in our CET Mathematics. First, one by one we are just go through. First section, function, limits, continuity and differentiability. For each and every section we are go through some important definitions and some of the problems which we needed for your entrance exam. First one, function, limit, continuity and differentiability. First definition, limit of a function. The function f is from a to b to r and x0 belongs to a comma b. Suppose that f is a function. Then we say that the function has a limit L if for every neighborhood there exists a neighborhood x0 minus delta and x0 plus delta, such that f of x belongs to L minus epsilon to L plus epsilon. So this is a definition for your limit of a function. That is, when a function f has a limit L. Next, second definition, continuity. The function f is from, let us assume that A is a set of x comma y, where x lies between a and b and y lies between c and d, and f is a function from a to r. We say that f is continuous at u comma b if the following holds. First one is, it should be defined at u comma b and the limit should exist, and L is nothing but capital F of u comma b. Next, differentiability condition. Definition for a differentiable function. Let f is a function from a comma b to r, then the differentiable function for x a comma b is defined as df is equal to f dash of x into delta x. These are the some of the definitions in this section. Let us go through the problems. Some of the important problems in this section we are just going through. First one, if f is function from r minus of 3 by 5 to r can be defined by f of x equal to this thing, then find the answer. Either it belongs to f inverse of x is f of x, or it belongs to minus f of x, or f composition of f of x is minus x, or which is thing. So we have to calculate f inverse of x first of all. Then we can compare whether it belongs to f of x or minus f of x or anything else. F inverse of x check பண்ணும்போது we just find the answer. So first calculate the thing. Here the answer is A. By finding f inverse of x, we get the same as an f of x. That's why we just choosing the answer A. Here is the explanation. Suppose given that f of x is nothing but 3x plus 2 by 5x minus 3. Then f of x is taken as an y. So y is equal to 3x plus 2 divided by 5x minus 3. On cross multiplying, we just get the answer as an 3x plus 2 equal to 5xy minus 3y. Which implies on taking x alone in the left side, we just getting x is equal to 5y plus 2 divided by 5y minus 3. Which implies f inverse of x is equal to 3x plus 2 by 5x minus 3, which is same as our given equation. So f inverse of x is equal to f of x. That's why the answer is A. So in all the options A, B and D, we are getting f inverse of x. So it's necessary to calculate the f inverse of x for the given function. Then we can calculate the answer. Next question. Second one. Let f is a function from 2 to infinity to r. Defined by f of x is equal to x square minus 4x plus 5. Then the range of f is what? We are taking f is from 2 to infinity, start from 2 and it goes on up to infinity to r, going to r. They are asking the range, it means the f lies between which and which number, starting and the ending number they are asking. Whether it may be r or 1 to infinity or 4 to infinity or 5 to infinity. Just we have to calculate. The answer is B. Means the range of f lies between 1 and infinity. How we can calculate? Just an explanation. Take f of x as x square minus 4x plus 5. F of x is taken as a y. So y is equal to x square minus 4x plus 5. Therefore y is nothing but we have to rewrite the given equation in terms of perfect square. In order to write in a perfect square, we have to divide the coefficient of x by 2 and squaring the value and adding and subtract, we just get a perfect square. It means x உடைய coefficient 2 ஆல் divide பண்ணி square பண்ணி plus and minus பண்ணாக்கா we can calculate the perfect square terms. That's why in this way we just divide x உடைய coefficient 4. So 4 divided by 2 is nothing but 2. 2 square பண்ணும்போது it gives answer 4. So we have to add and subtract 4. This means plus 4 minus 4. So the equation can be rewritten as x square minus 4x plus 4 minus 4 plus 5. On comparing the first three terms, we rewrite the given equation as y is equal to x minus 2 the whole square minus 4 plus 5. On solving this, we get y minus 1 is equal to x minus 2 the whole square, which is nothing but x minus 2 is equal to root of y minus 1. Means x is equal to 2 plus root of y minus 1. They have given that our x belongs to starting from 2 to infinity. So it implies that our value of y minus 1 should always greater than or equal to 0. Either it may take a 0 value or greater than or equal to 0. So which implies our y takes the value of greater than or equal to 1. Therefore, this implies that our range of the given function is nothing but starting from 1 to infinity. Thus, the range is nothing but 1 to infinity. It belongs to the option B. That's why we are choosing the range of the given function f of x equal to x square minus 4x plus 5 as 1 to infinity. Next question. Third one. Let f is a function from R to R. Be the function defined by f of x is equal to x cube plus 5. Then f inverse of x is dash. They are asking about the inverse function. We have to calculate the f inverse of x. The option is B. How we get answer B? Just an explanation. Take given as an f of x equal to x cube plus 5, which implies y is equal to x cube plus 5. Then x cube takes the value as y minus 5, which implies our x is equal to y minus 5 the whole power 1 by 3. Thus, we get f inverse of x is nothing but x minus 5 the whole power 1 by 3, which belongs to our option B. That's why when f inverse of x values takes answer as x minus 5 the whole power 1 by 3. Next sum. If the relation R on the set 1, 2, 3 be defined by R is equal to 1, 2, 2, 3, 1, 3, then R is dash. Either reflexive or transitive or symmetric or none of this. We have to find the answer. For this we have to know the definition of a reflexive. What is the reflexive? A related to A means reflexive. 1 related to 1, there is no relations. So this is not reflexive. Okay. What is meant by symmetric? If 1 related to 2, then 2 related to 1. There is no 1, 2 only alone. There is no 2, 1. So it does not belong to symmetry. Then either it may be transitive or none of them. Okay, let us see what the answer is. Our answer is B, transitive. Here is your explanation. That they have given that R is equal to 1, 2, 2, 3 and 1, 3. This implies that our R is transitive because as 1, 2 is in R and 2, 3 is in R, we have 1, 3 is in R. Means, what is my transitive definition? If A related to B and B related to C, then A related to C. This is not our transitive definition. It follows our transitive definition. So that's why the relation R and the set is defined by this is nothing but transitive. Next, we go to the next sum. The maximum number of equivalence relation on the set A is equal to 1, 2, 3 or dash. What is the maximum number of equivalence relation? We can find on the set. If our set is A is equal to 1, 2, 3, then we have to calculate the equivalence relation and we have to find the maximum number of equivalences. The answer is nothing but answer is 5, which is in the option D. Here is your explanation. Let us find the equivalence set. First equivalence sets are nothing but 1, 1, 2, 2, 3, 3. Okay. Then according to 1, 1, 2, 2, 3, 3 and along with that we are adding 1, 2 and 2, 1. These two are also equivalence relations. Okay. Then the second possibility is nothing but 1, 3 and 3, 1. Okay. Next 2, 3 and 3, 2. Okay. Next there is another one which we can calculate a square. A into a. It means all the things 1 to 1, 1 to 3, then 2 to 1, 2 to 3, then etc. Which implies a square. A into a, all the 9 values. Here they are asking about the number of equivalence relations. So we can calculate 5 equivalence relations in case of R1, R2, R3 and R5. So they are asking the maximum number of equivalence relations. So answer, there is one equivalence relation. Yes, there are one equivalence. We can find 2 number of equivalence. We can find 3 number of equivalence. Also we can calculate 5 equivalence. But they are asking about our maximum number of equivalence. So our answer is 5. Here are some of the exercise problem for your solving. Just prepare this section and just go through it and we can solve yourself and you can check yourself whether you know the answer or not. By this you can practice for your exam. These are some of the questions in this section. Next thing. Next we are go to the next second chapter, which is nothing but inverse trigonometric functions. Some definitions for this section. First one, periodicity. A real valued function is periodic if f of x plus p equal to f of x. We say that. The smallest of all such number is called period of function f. Here the p is said to be the period. For instance, for an example, we can calculate for sin x, cos x, cosec x and sec x and e power I x. They are all periodic function with period 2 pi. Again, in the same way, for tan x and cot x, they are all periodic function with the period pi. These are some examples for the periodic function. So, a function is said to be periodic if f of x plus p is equal to f of x. Next, we have to know whether the given function is odd or even. First thing, the function is said to be even. When the function is said to be even, in the sense, f of minus x is equal to f of x. If f of minus x oda value f of x oda value same avudo, then we say that the given function is an even function. In the same way, if we get an answer of an f of minus x is minus times the given function, it means minus of f of x, then we say that the given function is an odd function. In this way, even and odd are splitting. If the given function on replacing our x by minus x, if we get the same answer means it is even. If we get the answer in terms of minus times the same given quotient, in the sense we say it is an odd function. Some of the examples for an even and odd function. For even function, we just have square terms. All square functions are said to be an even functions. So x square. Again, cos x and sec x are even functions. For an odd function, x cube, odd powers of anything, x cube, x5, etc. x power 5, sin x, cosecant x, tan x and cot x. They all belong to odd functions. Next, some of the reading values. We just construct the following table to identify some known coordinate pairs of the point x, y on the graph. Y is equal to sin x where x lies between 0 to 2 pi. We just know about up to pi by 2. So you need to memorize up to 2 pi. For 0, you just 0. For pi by 6, 1 by 2. We know that 0, 1 by 2, 1 by root 2, root 3 by 2, 1 and 0. For pi by 2, we just get an answer as 1. Other than this, you have to memorize. For pi, it takes 0. For 2 pi, it takes 0. For sin x, for any multiple number of pi or 2 pi or 3 pi or etc. anything else, we just get an answer as 0. In the intermediate, that 3 pi by 2, it takes the value as a minus. Second definition for a sine inverse of x. For minus 1 to plus 1, wherever x for our x lies between minus 1 to 1, we just define sine inverse of x as a unique number of y in the range of minus pi by 2 to plus pi by 2, such that sine y is equal to x. In other words, the sine inverse sine function, sine inverse of x is a function from minus 1 to 1 to minus pi by 2 to pi by 2. It is defined by sine inverse of x is equal to y, where our sine y is equal to x and our y belongs to minus pi by 2 to plus pi by 2. Next, this is the graphical representation for your better understanding. The first figure 4.7, it indicates sine x in the range of minus pi by 2 to pi by 2. Next thing, which is nothing but sine inverse of x in the range of minus 1 to plus 1. Last one, figure 4.9, indicates both sine x and sine inverse of x. This is for your reference. In the same way, we can calculate for cos x. First, we just calculate this for sine x. In the same way, there is a tabulated value for the coordinate pairs x, y for the graph y is equal to cos x, where x in 0 to 2 pi. First, take this value of n 0. X takes the value of 0, pi by 6, pi by 4, pi by 3, pi by 2 and pi, 3 pi by 2, 2 pi, etc. For y, we just know the answer up to pi by 2. 1 root 3 by 2, 1 by root 2, 1 by 2, 0, anything, etc. Other than that, apart from that, we just have to memorize what's for pi. What it value, it takes value what? For pi, it takes as a minus 1. For 2 pi, it takes as 1. It means, what means? For odd multiple of pi, we just takes a value as a minus 1, and for even multiple of pi, it takes the value as a plus 1. For 3 pi by 2, it takes value 0. This is the tabulated representation. Next thing, definition for cos inverse of x. For x belongs to minus 1 to plus 1, we define a cos inverse of x as a unique number y in 0 to pi, such that cos y is equal to x. It can be represented as cos inverse of x is equal to minus 1 to plus 1 to 0 to pi, which is defined by cos inverse of x equal to y if and only if our cos y is equal to x and y belongs to 0 to pi. This is your graphical representation. We duplicate the graph of both y is equal to cos x and y is equal to cos inverse of x for your reference. 4.13 define our cos x, whereas 4.14 represent for our cos inverse of x. Next thing, for this section we just go through some of the problems. First one, problem number 1. The value of tan inverse of tan of 9 pi by 8 is dash. They are asking about tan inverse of tan theta. So we have to calculate. What's our answer? The answer is B. It means pi by 8. How we calculate pi by 8? Tan inverse and tan getting cancel each other. We just get a 9 pi by 8. No? Then how we can? We can't cancel directly tan inverse and tan. Okay? How we can go through? Just see the explanation. This can be solved as tan inverse of tan of 9 pi by 8. It can be written as 9 pi by 8 can be rewritten as pi plus pi by 8. Both are same. On solving pi plus pi by 8, we get 9 pi by 8. So tan inverse of tan pi plus pi by 8. We know that tan of 90 plus theta is nothing but tan theta. So we get tan inverse of tan of pi by 8. So which implies answer is pi by 8. So our option is nothing but B. Next thing, problem number 2. The domain of the function cos inverse of 2x minus 1 is dash. What's the domain for the function cos inverse? We have to calculate which range it lies between. That means our y, the domain is nothing but, answer is nothing but 0 to 1. The domain range lies between 0 to 1. Here is your explanation. This can be solved as f of x equal to cos inverse of this thing. Okay. We know that our cos inverse of function lies between in cos inverse of x, our x lies between minus 1 to plus 1. So our 2x minus 1 lies between the range of minus 1 to plus 1. On solving the equation, we just get minus 1 to left side on both right side, which implies 0 should less than or equal to 2x, less than or equal to 2. Means our 2x lies between 0 to 2. On divided by 2, we just get our x lies between 0 to 1, which implies x takes the value from 0 to 1, which is nothing but in our option A. Next thing, the number of real solutions of the equation is dash. They are asking the real solutions. How many solutions they are not asking. They are asking how many number of real solutions are there for this equation. Okay, let us go through. The answer is maybe 0 to 1 or infinity. Okay, just calculate it. But the answer is 0, which is in the option A. Here is your explanation. We can take the equation root of 1 plus cos 2x is equal to something. Okay. You can replace our cos 2x by 2 cos square theta minus 1. Cos 2 theta can be written as 2 cos square theta minus 1. In that way, we are replacing cos 2x is equal to 2 into cos square x minus 1. Okay. Then plus 1 minus 1 getting cancelled. Then root of 2 into cos square x is equal to root 2 into cos inverse of cos x. Okay. Then taking square root on left side, we just get root 2 into cos x. Cos square goes to cos x. So root 2 into cos x equal to root 2 into cos inverse of cos x, which implies root 2 getting cancelled. Then cos x is nothing but our x, which implies cos x equal to x means it is not true for all any real value. It means it has no solution. It has no real number of solutions. So the number of real solutions for this equation is nothing but 0. We can't get the real solution. It means the number of solution is 0, which is in the option A. Next question. Question number 4. They have given in terms of tan inverse and they are asking in terms of cot inverse. See the question. Just tan inverse of x plus tan inverse of y is equal to 4 pi by 5. Then calculate cot inverse of x plus cot inverse of y. Okay, we have to, so they have given tan but asking in cot. So we have to convert our tan to cot. But the answer is in option A. See the explanation? We have to convert our tan to cot. How we can convert? Tan inverse of x is equivalent to 90 minus cot inverse of theta. So we are replacing pi by 2 minus cot inverse of x plus pi by 2 minus cot inverse of y. Okay, we know that cot inverse of x plus cot inverse of a. Pi by 2 plus pi by 2 is nothing but pi. On taking the pi alone in the right hand side, we just get minus of cot inverse of x plus cot inverse of y is nothing but 4 pi by 5 minus pi. On solving, we just get minus 5 by 5. Taking minus both sides cancelling, we just get answer as an cot inverse of x plus cot inverse of y is equal to pi by 5, which is in option A. So our option is, our answer is A. Here we are using only one formula, which is nothing but tan inverse of theta is equal to 90 minus cot inverse of theta. Next question number 5. Find the value of 2 into sec inverse of 2 and sine inverse of 1 by 2. We have to calculate. The answer is 5 pi by 6, which is in the option B. See the explanation. So 2 into sec inverse of 2 plus sine inverse of 1 by 2 they have given. So we have to convert our 2 in terms of sec and 1 by 2 in terms of sine. So by converting, we know that secant, in where secant we get the answer of 2 in sec pi by 3. So 2 into sec inverse of sec pi by 3 plus sine inverse of sine pi by 6. And cancelling sec inverse and sec, sine inverse and sine, we just get 2 into pi by 3 plus pi by 6. On solving this, we just get an answer as a 5 pi by 6, which is in our option B. So our answer for 2 into sec inverse plus sine inverse is nothing but 5 pi by 6, which is in our option B. These are some of the problems in this section. Here we are given some of the exercises for you to solve. For your practice, prepare the section first of all and you just go through some of the MCQ problems and you can practice these questions and you can check whether you covered the chapters or not. These are some of the questions for your practice and we have given the answers also. If you need anything in the sense, you can send the explanation, you can send the queries, we can just give you the explanations too. Okay, these are some of the problems in our second chapter. Next, chapter 3, determinants and matrices. First, what is meant by matrix of cofactors? We know about the matrices. For any square matrix, the matrix of cofactor is defined as matrix obtained by replacing each element of Aij of A with its corresponding cofactor of Aij. The adjoint matrix is denoted by adj A, which is nothing but transpose of the matrix of cofactors of A. Transpose of the matrix of cofactors of A. ஒரு A உடைய cofactors matrix எடுத்தீங்கன்னா அதனுடைய transpose எடுத்தீங்கன்னா அந்த பேரு தான் என்ன சொல்லுவாங்க adjoint matrix னு மீன் பண்ணுவாங்க. Next thing, inverse. When a matrix is said to be inverse, if two matrices A and B of order n, then A cross B, AB is equal to BA is equal to I in the sense, it means identity matrix in the sense, then B is equal to be an inverse of A. Next thing, orthogonal definition. A square matrix is said to be orthogonal if A transpose equal to A transpose into A is equal to I. You know about transpose. Transpose in the sense we have to convert our rows into column and columns into row. That's why we are calculating our A transpose. So we have to product both A and A transpose as well as A transpose into A. If both values takes the value as an identity matrix, then the matrix A is said to be an orthogonal matrix. Next thing, rank of a matrix. It is denoted by row of A. Rank of the matrix is nothing but an order of highest order non-vanishing minor of the matrix A. Non-vanishing minor nuடைய highest order என்ன இருக்குதோ அதை சொல்றது தான் அந்த ஆர்டர் சொல்றது பேர் தான் rank of the matrix. It is clearly known that the rank of a zero matrix is defined to be 0. Otherwise, it should be at least 1. Next thing, a system of linear equation having at least one solution. We are having a system of many solutions, many equations. If a system of a linear equation it has at least one solution means then it is said to be consistent. If the linear equation has no solution in the sense, then it is said to be inconsistent. These are some of the definitions in the matrices and determinants chapter. We just go through some of the problems for your practice. First one, if A is a square matrix such that A square equal to A, then calculate 1 plus A the whole cube. They have given about A square equal to A, but asking about the cube. But the answer is nothing but A. It means 7A plus I. How they find out this? Here is your explanation. They have given A square equal to A. Therefore, first I plus A the whole cube they are asking. So I plus A whole cube can be written as I plus A into I plus A into I plus A. On multiplying the first two, we just get I square plus 2AI plus A square into I plus A. We know that as A square is equal to A, we just replace the first equation as an I plus 2A plus A. On adding this, we just get I plus 3A into I plus A. On multiplying and substituting the value for A square as A, we get 1 plus 4A plus 3A, which is nothing but 1 plus 7A, which is nothing but in our option A. So, if A square equal to A, then the value of I plus A the whole cube is nothing but 7A plus I. Next, second question. If A is equal to matrix of 1, 2, 4, 1, 2 by 2 matrix, then calculate the value of something, A square plus 2A plus 7A. Not necessary this equation, they can ask about something else also, that A cube plus 3A, 7A, etc. anything else. This is very much simple. How you can calculate in a sense, they have given the answer in this way. Okay, but the answer is D. How they calculated? Just substitute the value. Find A square in the sense A into A. Okay, then substitute into A square plus 2 into A plus 7 into I. On solving these three, we just get a matrix as 18, 8, 16, 8, 18, which is in our option D. So the answer for this is D section. Next question. The cofactor of A12 in matrix listing. So we have to calculate the cofactor. where in the position of A12. It means in first row second column. So we are going to calculate the cofactor for the term of minus 3. What is the answer? Here the answer is A. Here is your explanation. Cofactor of A12 is nothing but minus 1 power I plus j into the minor of that matrix, which is nothing but minor of that particular element. It means minus 3 இருக்கக்கூடிய row and column விட்டுட்டு remaining இருக்கக்கூடிய அந்த elements and determinants எடுப்போம். So minus 1 power I plus j is nothing but 1 plus 2. So minus 1 power 3 into modulus of this thing. So A12 is nothing but 46. Next question. The total number of possible matrices of order 3 by 3 with each entry 2 or 0 is dash. They are given the total number of possible matrices. It means we have to calculate the possible matrices of order 3 by 3 in which each and every entry is either 2 or 0. So we have to calculate. The answer is nothing but D. It means 5, 1, 2. Here is the formula. For each entry of 2 or 0, the total number of possible matrices is in the formula of 2 power n. N is nothing but number of entries in the given matrix, which is nothing but 2 power 9. They are asking about for 2 or 0, so 2 power. If they are asking about 1, 2, 3, in the sense you have to calculate 3 power n. So etc. So for this 2 power 9, 2 power 9 is nothing but 5, 1, 2, which is in our option D. So this thing is answer. So D is our answer. Here are some of the exercises for your practice. Just go through the exercises and solve it and find the answer. We have given the answers also for your reference. Just prepare for this section. These are some of the topics in this chapter. Next we go to the next section, differentiation and application of derivatives. First we have to find the slope. What is meant by slope? Slope is otherwise called as a gradient. The definition for slope is nothing but f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. It means the slope of the line joining the 2 points x and x plus h is given by this thing. Slope of the point at the x comma y or x comma f of x. This is the definition. Next, question 1. First one, if x power m into y power n is equal to x plus y the whole power m plus n, then find the value for dy by dx. They have given x power m, y power n and asking about dy by dx. It means we have to differentiate the given equation once and calculate value of dy by dx. So we have to calculate dy by dx. Find the answer. The answer is nothing but B, y by x. Here is your explanation. Take the given equation, x power m, y power n. Having powers in the sense we can't differentiate. So we just take a log on both sides. On taking log on both sides, m log x plus n log y is equal to m plus n into log of x plus y. Then now we have to differentiate. On differentiating, first thing we just get m by x, second one plus n by log x differentiation 1 by x. So log y means 1 by y into dy by dx. Here 1 by x plus y into, on differentiating log of x plus y, we just get 1 by x plus y into log பண்ணிட்டோம், திரும்ப உள்ளார வந்து உள்ள இருக்க ஃபங்க்ஷன்ஸ் பண்ண போறோம். அப்ப x plus y differentiate திரும்ப பண்ணணும், which is nothing but 1 plus dy by dx. On solving this, we get m by x plus n by y into dy by dx equal to m plus n by x plus y plus m plus n by x plus y into dy by dx. Taking dy by dx alone in the left side and the remaining in the right side. On solving this, by taking our LCM, we just get an answer as an nx minus my by y into dy by dx equal to nx minus my by x. On solving, on cancelling the common terms, we just get dy by dx as y by x, which is in our option B. That's why the answer for this function is B. So simple, what we have done, taking logarithm, first step taking log on both sides, second taking differentiation and separate dy by dx alone in the left side. So we calculate the answer. Next, question number 2. Next question number 2, this thing. Okay, if x is equal to, they have given one expression, then asking about to find calculate dy by dx. Okay, we have to calculate dy by dx. Same thing. They have given, first problem they have given in terms of powers. Here they have given in terms of root. Okay, we just go through x into root of 1 plus y. Separate the equations into two sides. Given equation is in terms of a root. So, on taking logarithm is impossible. So, impossible not, that's absurd. So, we can solve this equation. By treating it as a root, we can solve little bit difficult. So, first step, we just square on both sides and then we just differentiate. So, on squaring the above equation, we just get x square of 1 plus y is equal to y square of 1 plus x square and the root getting cancelled. Then multiplying x square, multiplying y square, both the sides. Next thing, x square minus y, we are keeping x square y square alone in this side and both the combination of x and y in this right side. It can be written as a plus b into a minus b formula, and in the right hand side, taking the common outside, we just get x minus y. Cancelling the common terms on both the sides, we just get x is equal to minus y into 1 plus x. Now we have to differentiate this thing. On differentiating, we just get right hand side y into 1 minus x, left side x. On differentiating x, we just get 1. On differentiating the right side, on y into y differentiate pannamadhu product rule. Minus y into 1 plus x. So, minus 1 plus x into dy by dx minus y into then next term. So, uv differentiation pannamadhu u into v1, sorry, u into v dash minus v into u dash. So, minus y. So, taking dy by dx alone in the left side and the remaining in the right side, we just calculated as and we just find the answer as minus of 1 plus y by 1 plus x, which is in our option A. That's why the answer is A. Next question number 3. If f of 2 is equal to 4 and f dash of 2 is equal to 1, then the value of limit x tends to 2. Find this thing. They have given value for f of 2 and f dash of 2, but they are asking the value for x into f of 2 minus 2 into f of x. So, from this itself we just understood we have to convert our f of x to something either to f of 2 or f dash of 2. Okay, we just find the options are 0, 2, 4 and 8. The answer is B. How they get the answer? See the explanation. Just given question is limit x tends to 2 of this thing. We have to subtract and add and subtract 2 into f of 2 on both the sides. So limit x tends to 2, x into f of x 2 minus 2 into f of x minus 2 into f of 2 plus 2 into f of 2. Minus and plus. We are subtracting and adding and subtracting 2 into f of 2. Then first term and the third term taking, the second and the fourth taking. So we are separating 1 and third. On taking 1 and third f of 2 as a common, we just take x minus 2. From second and fourth, we just take 2 as a common, we just take f of x minus f of 2. We know the definition, just splitting the limit into 2 equal halves. First term limit, second term limit. Next, on second limit, we just find that it is nothing but the definition for a derivative. So, limit x tends to 2, f of x minus f of a by x minus a means f dash of a. In that formula, here a is nothing but 2. So, we substitute limit x tends to 2, f of 2 minus 2 into limit x tends to 2, f dash of 2. We know both the values, f of 2 and f dash of 2 in the questions. Substitute the value and we just get an answer as a 2, which is in our option B. So, the value of limit x tends to 2, x into f of 2 minus 2 into f of x by x minus 2 is nothing but 2. Next question. If x is equal to root of a into sine inverse of and y is equal to root of a by sine cos inverse of t, then calculate this. Okay. The answer is nothing but D. How they are getting? Just find out. A is equal to root of. In this C, they have inverse, they have power, they have root. So 3 terms. Root. For root, first we have to delete our root. For demolishing root, what we have to do? We have to square. So on squaring both the sides of x, we just get, they are asking dy by dx. For both the sides of x, we just get x is equal to a into sine inverse of t. On squaring both the sides, we get x square is equal to a into sine inverse of t. Then taking log. On taking log, we just get 2 into log x. We are applying log of x square on log power வந்து ஃப்ரண்ட்ல வரும். அந்த கான்செப்ட் யூஸ் பண்ணுவோம். 2 into log x is equal to sin inverse of t into log a. Now we are going to differentiate. On differentiating this, we just get 2 by x into dx by dt is nothing but, on differentiating sin inverse of t, sin inverse of x differentiate பண்ண என்ன வரணும்? 1 divided by root of 1 minus x square. Here x is nothing but t. So differentiation of sin inverse of t formula use பண்றோம். 1 divided by root of 1 minus t square into log a, as it is log a. Here log a is taken as a constant. So keeping dx by dt alone in the left side, we just get an answer as an x into log a by 2 into root of 1 minus t square. In the same way, we have to calculate dy by dt. Here they have given y is equal to a into cos inverse of t. So dy by dt, the same way we have to calculate, where cos inverse of t is, on differentiating cos inverse of t, first taking square root, then taking log, then differentiating. On differentiating, cos inverse of x is nothing but differentiation of cos inverse of x, nothing but minus 1 divided by root of 1 minus x square. On substituting the value, we just calculate dy by dt. But our question is nothing but dy by dx. So dy by dx is nothing but dividing 1 and 2. 1 and 2. We just get an answer as a minus y divided by x. It means we have to divide 2 by 1. We have to divide both 1 and 2. On getting the answer as a minus y by x, which is in our option D. So the answer for the question is minus y by x. Next section we just go through. Next section is nothing but indefinite integral and definite integral. Some of the basic needed for this sections is nothing but, for any function k, the indefinite integral is nothing but kx plus c. Same way, ax plus b the whole power n, in the sense you have to answer as an for indefinite integral, it takes the value as 1 by a into ax plus b the whole power n plus 1 by n plus 1. E power ax in the sense e power ax by a. Sin ax plus b in the sense minus cos ax plus b divided by a. These are some of the important formulas in indefinite integral. You have to know these things, that e power ax, sin, cos, tan, cot, etc. You have to memorize this thing. You have to know the answers so we can solve the problem little bit faster. And these are the important formulas for this section. For root of a minus x square, sin inverse of x by a. Next, definition for indefinite integral and both definite integral. First, definition for an indefinite integral. For an indefinite integral, we just have a definition as an integral f of x dx is nothing but capital F of x plus c, where f of x is any antiderivative of f of x. Okay. Next, definition for definite integral definition. Definite integral. What is meant by definite integral? Integral a to b f of x dx is nothing but f of b minus f of a. This is your definite integral. The upper one is indefinite integral, the lower one is definite integral. Next, here integral a to b f of x dx is read to be, we are integrating f of x with respect to x from a to b. First question, find the value or evaluate integral 2 to 5 x minus 2, x minus 3, x minus 5 dx. Here see, the question is not in an ordinary way. They have given the question in terms of modulus. So we have to little bit very much conscious to solve that problem. Here the answer is 23 by 2, which is nothing but answer C. See the explanation. They have given 2 to 5. In the range of 2 to 5, they are asking something. So we have to split the range 2 to 5 into anyway, either by 2 or 3 or 5. Because they have given in terms of 2, 3, 5 on that side. So the 2, that's impossible. So we have to divide the into 2 to 3 and 3 to 5. Okay, let us split the integral into 2 to 3 plus 3 to 5. On first integral, let us assume we have to remove the modulus value, then only we can integrate and substitute the answer. For that, by removing integral in the sense, it takes positive value in the positive region, negative value in the negative region. Okay, let us assume for 2 to 3 range, x minus 2 takes always positive, so as it is x minus 2. For 2 to 3, x minus 3 takes the value sometimes negative. If we substitute 2 in the sense, it takes negative. So modulus of x minus 3 is nothing but 3 minus x. So replace modulus of x minus 3 as 3 minus x. Similarly, the last one, in the range of 2 to 3, it takes negative value. So we have to replace our x minus 5 as 5 minus x. This is what happened in our range of 2 to 3. Next, in the range 3 to 5. Let us take the range. In 3 to 5, the first one x minus 2 we same as x minus 2. The second x minus 3 takes always positive, so no need to change as well as x minus 3. In that 3 to 5 means if we substitute 4 in the sense 4 minus 5 is takes the value minus 1. So it takes negative value. So you have to rearrange the term. X minus 5 can be written as 5 minus x. So we just split it and we just removed the modulus. Now it's an ordinary method. It's an ordinary. By ordinary method we have to solve and integrate. On solving the first term we get an answer as 6 minus x. On solving the second term we get an answer as x. On integrating 6 minus x we just get 6x minus x square by 2. On integrating x we get x square by 2. We have to apply our limits separately. For the first we have to apply 2 to 3. For the second one we have to apply 3 to 5. On applying upper limit minus lower limit, first we just integrated, then we have to apply upper limit minus lower limit. Upper limit is 3, lower limit is 2, plus upper limit 5 minus lower limit 3. On solving this we get an answer as an 23 by 2, which is in our option C. So the answer for the question is C. Next question number 2. Evaluate integral 1 to root 3 dx divided by 1 plus x square. We have to calculate, we have to evaluate the question and we have to find the answer for an integration. Here the answer is D. See the explanation? Let us take the integration as an I. On integrating this, we know the formula 1 by 1 plus x square means integral of 1 by 1 plus x square is nothing but tan inverse of x. Okay, tan inverse of x. Then the limit is nothing but 1 to root 3. Upper limit minus lower limit. So tan inverse of root 3 minus tan inverse of 1, which is nothing but pi by 12, which is in our option D. So the value for integral 1 to root 3 dx divided by 1 plus x square is nothing but pi by 12. Next question. Find the value of a if the integral takes the value as an 8. They have given integral 0 to a 3x square dx is equal to 8. We have to find the answer for our a. Either it takes 1, 2, 3 or 4. The answer is C. It means it takes the value 2. Here is your explanation. Integral 0 to a 3x square dx is nothing but 8. Taking 3 common away, constant, so outside. On integrating x square, we get x cube by 3. Limit 0 to a. On applying the upper limit minus lower limit. Upper limit means a cube by 3 minus lower limit is 0. 3 and 3 getting cancelled. So a cube is equal to 8 means we just get an answer for a as a 2. So the answer is 2, which is in our option C. Next question. Integral log of 1 plus x square into dx. We have to calculate the value for log of 1 plus x square integration. The answer is A. Here is your explanation. Integral log of 1 plus x square. On integrating this, we just have log x dx. There is no straight away formula. So we are applying the formula as u dv. Integral u dv. We know the formula u dv as uv minus integral v du. Here u takes the value as a log. V takes the value dv as dx. Then dv as a dx in the sense, then v is nothing but x. So u into v. Log of 1 plus x square into x. U is nothing but log, v is nothing but x. uv minus integral v into du. V here nothing but x. X into du. So you have to differentiate our log of 1 plus x square. On differentiating, we just get 1 by 1 plus x square into 2x. So answer is nothing but I is equal to x into log of 1 plus x square minus 2 into integral of x square by 1 plus x square dx. We have substituted the formula as integral u dv is equal to uv minus integral v du. Okay. On solving that, first term over, then the second term. In second term, x square by the denominator as 1 plus x square. So in order to eliminate, we just apply plus 1 minus 1 on the numerator. So we just get 2 into integral dx plus 2x. It means we just taken first two terms, x square plus 1 by 1 plus x square, both getting cancelled. So we get 2 into integral dx. Second term, minus of minus plus 2. 1 divided by 1 plus x square. We know the formula for integral 1 plus x square, because we know the equation should involve, all our options are containing tan inverse of x. So it should contain 1 by 1 plus x square term. Then only we just integrate taking the value as a tan inverse. So in order to bring our tan inverse of x, we have introduced plus 1 minus 1 in the previous step. Then now it is nothing but integral of this thing equal to tan inverse of x. So our answer is I is equal to x into log of 1 plus x square minus 2x plus 2 into tan inverse of x, which is in our option A. So the answer for the question is A. Next question. Integral 1 by x sin square x into cos square x dx. Calculate the integral. Okay. So we have to calculate the integral value. This answer is in option C. For your explanation, see the explanation. Take the given equation 1 by sin square x cos square x. In order to eliminate the denominator, we introduced our trigonometric formula sin square x plus cos square x equal to 1 in the numerator, and splitting the equation into two half. It means sin square by sin square x cos square x plus cos square x divided by sin square cos square. We have just split it into two terms. Then cancelling the common term, we just get first term as integral 1 by cos square x. Second term as 1 by sin square x. 1 by cos square is nothing but secant square. 1 by sin square is nothing but cosecant square. On integrating, we just get integral sin square of x is equal to tan x. Integral cos square of x is nothing but minus cot x, which is in our option C. So the answer for our given question is C. This is what we have in this section. Next, move on to the next section, differential equations. In this section, we just go through some of the little formulas, needed formulas. First one, a differential equation. What is meant by differential equation? A differential equation is nothing but an equation which contains at least one derivative of unknown function. Either it is ordinary derivative or partial derivative, whatever it may be. If it contains at least one derivative in an equation, means then the equation is said to be differential equation. Next thing, ordinary differential equation. What is the order of a differential equation? The order is nothing but the highest order derivative present in the differential equation. And the differential equation derivative highest power and the highest order in the order of the derivative of the equation involved, it is said to be the order of the differential equation cycle. Derivative highest order that is the equation highest, that is the equation order. Next, degree. What is meant by degree? Degree is expressed in a polynomial form. Let the differential equation is expressed in a polynomial form. Then the integral power of the highest order derivative appears is called degree. It means the highest order derivative appears integral power. Highest derivative power, it is said to be the degree of the given differential equation. Next, ordinary differential equation and partial. What is meant by ordinary? What is meant by partial? In a differential equation contains only ordinary derivatives of one or more function with respect to a single independent variable. It is said to be ordinary differential equation. In a partial means if an equation involving only partial derivative, whereas in ordinary they involve only ordinary derivatives. Here they involve only partial derivative of one or more function of two or more independent variable. It is said to be partial differential equation. We represent ordinary differential equation as an ODE, partial differential equation as PDE. The general form of an ordinary differential equation of order n is expressed as in the equation. like equation 1, whereas here a1 of x, a0 of x, etc. are any functions of independent variable x. This is our general equation. The last one is. Next, we go through some of the problems in this section. Problem number 1. Write the differential equation representing the family of the curves y equal to mx, where m is an arbitrary constant. M is an arbitrary constant. In the family of curve, ஒரு differential equation கொடுங்க. This is my question. The first one answer for this question is A. See the explanation. We have y equal to mx. On differentiating, we just get dy by dx as m. From our given equation, y is nothing but m is nothing but y by x. On substituting here, we just get dy by dx is equal to y by x. On cross multiplying, we get an answer as x dy minus y dx equal to 0, which is in our option A. So, the differential equation representing the family of curve y equal to mx is A. Is in option A. Next, question number 2. The general solution of a differential equation dy by dx equal to log x is dash. They are asking about the general solution. Either A, B, C or D. But our answer is C. Explanation. Given dy by dx equal to log x. They have given dy by dx equal to log x. Okay. On separating, dy is nothing but log x into dx. Just integrate. So we have to eliminate the differentiation. So just integrate. On integrating, integral dy is nothing but y. Integral log x is nothing but you have to integrate in the sense that there is no straightaway formula, which is in the formula of integral u dv. We know the formula u dv is equal to uv minus integral v dq. Here u takes the value as a log x, dv takes the value of a dx. So u into v, u log x, v is nothing but x. So log x into x, nothing but x log x, minus v into d, v is nothing but x. On differentiating log x, we get answer 1 by x. So y is equal to x log x minus integral dx. On integral dx is nothing but x. So y is nothing but taking x common outside, log x minus 1 plus c, which is in our option C. So that's your answer. Next question. The order of a differential equation of all circle of radius r having center on y-axis and passing through the origin. They are asking about the order of a differential equation. Okay, the answer is 1. See the explanation. They have given the equation of the circle with the center on the y-axis and radius r. So equation is nothing but x square plus y minus h to the whole square equal to r square. This circle passes through origin they have given. So on substituting 0, 0 in place of x and y, we get h square equal to r square, which implies h equal to r. Therefore, the equation of the circle of radius r and center on y-axis passing to the origin is nothing but x square plus y minus r the whole square equal to r square. On expanding this, we get x square plus a minus b the whole square formula, a square plus 2ab plus b square. On expanding by using the formula, term y is missing, so y square minus 2yr plus r square equal to r square. On solving the equation, we get x square plus y square equal to 2yr. This equation contains only one arbitrary constant, which is input r. So we need to remove that. So the order of the differential equation is 1, which is nothing but the number of arbitrary constants denotes the order of the differential equation. Here the constant is 1, therefore the order of the differential equation is 1. Next chapter, vector algebra. Next we go to the next chapter, vector algebra, new section. Two vectors are said to be scalar. A vector is equal to, in the terms of a1i, a2j, a3k, and b vectors is in the way. Then the scalar product or a dot product, both are same. The scalar product is defined as a dot b is equal to a1 b1 plus a2 b2 plus a3 b3. On dot product, I dot I is equal to 1, so there is no vectors in a dot b, a vector dot b vector. Answer. The next thing, vector product or the cross product. It is denoted by A cross B and it is calculated by A vector cross B vector is equal to ijk modulus of ijk A1 A2 A3 B1 B2 B3. So on dot product we are multiplying, on cross product we are taking the determinant value. These are some of the properties for our dot product and cross product. Say if A and B are perpendicular to each other, then A dot B is 0. If A and B are parallel to each other, then A cross B equal to 0. For three vectors A, B and C, we just have A dot B as this thing and A cross B is equal to this thing. Next definition, work done. Work done by the force is nothing but W equal to F dot D, where F is nothing but the constant force on the particle and D is nothing but the displacement vector. Next, torque or moment. If a force F vector is applied on a particle at a point with a position vector A, then the torque is given by T is equal to R dot R cross F vector, which is otherwise called as a rotational force. For a rotational force, we have to multiply the position vector into the force by cross product. Next, scalar triple product. A cross B dot C is called as a scalar triple product. A, B, C, both cross product and dot product is that, which is nothing but a scalar triple product. Question number 1. If vectors I, J, they have given the two vectors, they represent the adjacent sides of a parallelogram, then we have to calculate the area of the parallelogram. We know what is the formula for our area of the parallelogram. Area is nothing but, the options are A, B, C, D and the answer is, they have given answer as a 8 by 823, which is in option C. We know that area is nothing but modulus of A cross B. Take the first given vectors as A, second one as a B. Then A cross B is nothing but modulus of ijk 1, 2, 3, 3 minus 2, 1. On solving that, we get an answer of our A cross B as 8i plus 8j minus 8k. Therefore, area is nothing but taking modulus on A cross B. On taking modulus, root of I square coefficient, j would coefficient square and k coefficient square, which is nothing but modulus of root of modulus of 8 square plus 8 square plus 8 square, which is nothing but 8 root 3, which is in our option C. Next question, question number 2. They have given the expression as A cross B the whole square plus A dot B the whole square as an 144 and they have given that modulus of A value as an 4. They are asking the value for B. Just go through the explanation. They have given A cross B whole square plus A dot B whole square. We know the formula for A cross B. A cross B whole square in the sense modulus of A square plus into modulus of B square is sin square theta. For case of dot, modulus of A square, modulus of B square into cos square theta. Okay. Taking common outside, we just get modulus of A square into modulus of B square is equal to 144. On substituting modulus of A value, we give 4 square is equal to modulus of B square. So, modulus of B square is equal to 144 by 16, which is nothing but 9. So, modulus of B square is 9 in the sense modulus of B equal to 3. That's why we calculate the value for an modulus of B, which is in our option B. Next question, question number 3. If A, B, C are mutually perpendicular vectors, each of magnitude unity, then modulus of A plus B plus C is dash. They are asking. If A, B, C are mutually perpendicular, both are mutually perpendicular of magnitude 1. Okay, the answer is 1, 3 or root 3 or 3 root 3. We just go through. They have given that all are equal and unity. They are mutually perpendicular and unity. So, mod A equal to mod B equal to mod C equal to 1. Then A dot B equal to A dot C equal to C dot B equal to A. By using the definition of perpendicularity, if two are they are perpendicular sense, then their dot product equal to 0. By using that, we just get 0. Now, calculate modulus of A plus B plus C. In order to calculate the modulus, we just square. Then A square plus B square C square plus 2 into A into B, 2 into A into C plus 2 into B into C. On substituting the value, we get 1 plus 1 plus 1, 3. So, modulus of A plus B plus C, the whole square is 3. So the modulus value takes root 3, which is in our option C. Which is in our option C. Okay. Next thing, 3D geometry. This is the previous section is nothing but completed. Next we go through the next new section, 3D geometry. Let us go through some of the problems in 3D geometry. First one, the coordinate of the foot of the perpendicular drawn from the point 257 on the x-axis are given by dash. They are asking the coordinates where from the foot of the perpendicular drawn from the point this thing on the x-axis. Okay, the answer is 200 because as the question, the foot of the perpendicular drawn from the point on x-axis, it takes y and z as 0. So the coordinates for y and z are 0. So the only answer is 200, which is in our option A. Next question. A line makes equal angles with coordinate axis. Then the direction cosine. Then the direction cosine for the given line is what they are asking. Okay, they have given that it makes an angle equal. Equal angle in the sense, then the direction cosines are nothing but cos alpha, cos alpha for all the three. Since cos square alpha plus cos square alpha plus cos square alpha equal to 1, they have given. Each are having the directional cosines as 1 unity. So since that is equal to 1, we have cos square alpha plus cos square alpha equal to plus cos square alpha equal to 1, which means 3 times cos square alpha equal to 1, cos square alpha equal to 1 by 3, then the direction cosine is nothing but cos alpha equal to 1 by root 3. Therefore, the direction cosines are 1 by root 3, 1 by root 3, 1 by root 3, which is in our option B. Next, third question. The direction cosine of the line x equal to y equal to z are. They are asking, in the previous question they have line makes equal angle. Here lines are equal, then what is our direction cosines? If the lines makes an angle alpha with each of the axis, we have same thing. The direction cosines of a line of an equal angle is equal to cos alpha, cos alpha, cos alpha. We have cos alpha is nothing but 1 by root 3. Therefore, the direction cosines are 1 by root 3, 1 by root 3, 1 by root 3, which is in our option B. So, B is our answer. Next section, linear programming. Last previous section, linear programming. The Russian mathematician applied mathematical model to solve linear programming problems. The Russian mathematician L.V. Kantorovich. He pointed out in 1939 that many classes of problems which arise in production can be defined mathematically and therefore can be solved numerically. By defining it in a mathematical model, we can easily solve it. That's why the linear programming problems are arises. First, the short form of a linear programming problem. How it appears? Linear programming problem in the sense, what are the format, what are the content it has? First one, maximum is it or minimum is it? It means the objective function. First line is objective function, it means it goes to define the problem. Either to maximize or to minimize. So, maximize or minimize is equal to summation j equal to 1 to n cj xj. Subject to the constraints or something equations where I lies between 1 to m and xj's are greater than or equal to 0. This is the short form of an LPP. So, linear programming problem appears in this model, in which what is the objective function. The first thing is a function is which is to be optimized, either to be maximized or minimized, is called the objective function. Next, the solutions. Sorry, decision variable. What is the decision variable? The decision variables are the variable which has to be determined xj to optimize the objective function. We need to optimize objective function, which has to be determined to optimize. That variables are said to be the decision variables. They are going to act as a decision variables. Next, constraints. There are certain limitations on the usage of limited resources, it is said to be constraints. Which is nothing but summation Aij Xj is either less than or equal to or greater than or equal to or equal to Ba is said to be the constraints of the given program. Next, solution. The set of value of the decision variables satisfying all the constraints is called the solution, in which the solutions may be either feasible or optimal. First, feasible solution. The set of value of the decision variable that satisfies all the constraints of the problem and non-negative restriction. Then the solution. If they have a solution in the sense they have to satisfy all the constraints, is said to be the solution. Whereas it satisfies all the constraints of the problem and no negativity restrictions is called feasible solution of the problem. Next, optimal solution. Any feasible solution which maximize or minimize the objective function is called optimal solution. Feasible region. What are the feasible regions here? The common region determined by the constraint, including non-negative constraint, is called feasible region. The feasible region is otherwise called the solution region. Okay. Let's go through the problems. Problem number 1. The feasible solution for a linear programming problem is shown in the figure. Then let z is nothing but 3x minus 4y be the objective function. We have to optimize z. It means we have to find the minimum of z occurs at. We have to calculate. They have given the figure. By seeing the diagram, we can't tell where the minimum value of z appears. The answer is given as in 0 to 8. On by seeing, we can't calculate either by 0, 0 or 5, 0 the minimum value. So we have to calculate the feasible solution. Here is your explanation. We have the corner points. We have the feasible region points. Construct the corner points and find the value of z for all the corner points. Substitute x and y 0, 0 in the z value. Substitute 5, 0 in the z value. Substitute 6, 5 in the equation of z. On substituting all those things, we can calculate the value of z for all the corner points. Among all the points, which one is minimum is our answer. If they ask in the question as maximize the z, then we have to calculate the maximum value. Maximum value will give the answer. Now, in this problem, they are asking to calculate the minimum of z occurs at which point. So, here the z value takes 0, 15, minus 2, minus 14, minus 28 and 32. The minimum value is minus 32, which occurs at the point of 0, 8. Therefore, the answer is 0, 8, which appears in the option B. Next, question number 2. The common region determined by all the linear constraints of an LPP is called a dash. This is nothing but a definition. The common region determined by all the linear constraints. The region determined by all the constraints is nothing but the feasible region. Okay. Next, any point in the feasible region that gives the maximum or minimum value of the objective function is known as dash. They are asking any point in the feasible region that gives maximum or minimum value of the objective function is called nothing but answer is optimal solution. In feasible region which optimize is called optimal solution. Next, question number 4. A linear function is equal to ax plus by where a and b are constants, which has to be maximized or minimized is called a linear objective function. Okay. The linear objective function is z equal to ax plus by. Here x and y denotes are known as what? The functions in the objective functions are nothing but the decision variables. So the answer is decision variable for question 4. Next, question number 5. Let R be the feasible region of a linear programming problem and let z equal to ax plus by be the objective function. If R is bounded, then the objective function is dash. Answer is it must have both maximum and minimum value of. Okay, if R is bounded in the sense, Then the objective function has both maximum value and the minimum value. Next chapter, probability. We go through some of the definitions in this section. Probability. The last section for your preparation. First, what is meant by random variable? A random variable is nothing but a function defined on the sample space S into the real number R such that the inverse image of a point or a subset or an interval is an event in S. That's called a random variable. The random variables are of two types: discrete random variables and continuous. For in case of discrete, we are using for counting the quantity. For continuous, we are using them for measuring the quantity. First, discrete random variables. A random variable defined on the sample space into the R is called a discrete random variable if the range of X is countable. That is, it can assume only a finite or countably infinite number of values. Next, probability mass function. If a X is discrete random variable, then the function denoted by f of xk is equal to p of x equal to xk is called probability mass function. Then for cumulative distribution function of a discrete random variable, it takes the value, taking the value as x1, x2, x3, also x1 less than x2 less than x3 etc. with the probability mass function is capital F of x, cumulative distribution function f of x equal to p of x less than or equal to x, which is nothing but summation f of x where xi is less than or equal to x. Next, properties of the distribution functions. For a discrete random variable, our cumulative distribution function should lies between 0 to 1. It is a real valued and non-decreasing function. F of x is a right continuous function. The limit of x tends to minus infinity takes the value as 0, and x tends to infinity of f of x takes the value as 1, and x lies between x1 and x2 of probability function takes the answer as f of x2 minus f of x1. Similarly, p of x greater than x is nothing but 1 minus p of x less than or equal to x. P of x equal to xk is equal to f of xk minus f of xk minus. These are some of the properties of a random variables. Next, all those things for discrete. Now we go for continuous random variables. For a continuous random variables, S is a sample space and let a random variable x takes any value in a set, then x is called continuous random variable. Probability density function is calculated as for each possible outcome x belongs to a comma b, p of a less than or equal to x less than or equal to b equal to integral a to b f of x dx. Next definition, cumulative for continuous random variable. F of x equal to p of x less than or equal to x equal to integral minus infinity to x f of u into du. Next, some of the properties of the distribution function. Next thing, these are the distribution function. For a continuous random variable, the cumulative distribution function lies between 0 to 1, and it should be real valued and non-decreasing. It should be continuous everywhere. It takes the value as a 0 to 1, same thing as a discrete random variable. These are some of the properties. Next definition for mean. Mean is calculated as E of x is equal to summation x into f of x. Next, for discrete case. For continuous case, it takes the value as integral minus infinity to plus infinity x into f of x. For variance, we calculated as v of x. Variance of x is nothing but e of x minus mu the whole square. This is for our Bernoulli distribution, and the next one is for our binomial distribution. Next, we go through some of the problems in this section. Problem number 1. Of the 4 numbers whose average is 60, the first one is 1/4 of the sum of the last 3. They have 4 numbers and they have given the average as 60. And they have mentioned the first one is nothing but 1/4 of the sum of other three. The second number is 1/3 of the sum of the other three, and the third is half of the other three. Find the fourth number they are asking. Okay, we have to calculate either it belongs to A, B, C or D. But our answer is in A. See the explanation. Let us consider the four numbers as A, B, C and D. They have mentioned that the first number A is nothing but 1/4 of B plus C plus D. So which implies 4A is equal to B plus C plus D. But we know that average is nothing but 60. So average is nothing but A plus B plus C plus D by 4 equal to 60. On replacing B plus C plus D as 4A, we get 5A by 4 is equal to 60. On cross multiplying and calculate the value for A as 48. In the same way, we can calculate our answer for B and C. They have mentioned first term as 1/4, the second term as 1/3 of the sum of other three. It means B equal to 1/3 times of A plus C plus D. And third term is half of the other three. Third is nothing but C. So C is equal to 1/2 of A plus B plus D. On solving this, we can calculate the value for A, B and C. And they have mentioned that its average as 60. So A plus B plus C plus D equal to 240. On substituting A value, B value, C value, we calculated our D value as 52. That's our option A. Next question. The average annual income of a certain group of illiterate workers is A. They have mentioned. And that of other worker is W. The number of illiterate worker is 11 times that of other workers. Then the average monthly income of all the workers is dash. They have mentioned two things. One is illiterate workers and the other one is non-other workers. The average annual income for illiterate is A and for other workers is W. Okay, the option answer is D. See the explanation. Let the number of other workers, let us assume that the other workers as X. So the number of illiterate workers as 11X. They have mentioned the number of illiterate workers is 11 times the other workers. So if we take other workers as X, the number of illiterate workers as 11X. Next, the total number of workers. Overall total is nothing but 12X. They have given the total income for illiterate workers is A. So 11AX. Next, the total income of other workers is X into W, XW. Well, 11W but 11A. I just missed it. 11AX, here X into W. So the combined overall total is nothing but 11AX plus 11X. Taking average, overall total divided by the total number of workers. So 11AX plus WX divided by 12X, which is nothing but 11A plus W by 12, which is in our option D. So the answer is D. Next question. The average of 5 positive numbers is 99. The average of first two and the last two numbers are days and days. What is the third number? They have given the average and asking about our third number. Okay, let us see. They have given the 5 numbers average as 99. So the sum of 5 numbers, nothing but 5 into 99. So which is nothing but 495. The average of first two number is 117. So the sum of first two numbers, nothing but into 2, 234. And the average of the last two number is nothing but 92. They have given. So sum of the last two numbers is nothing but 92 into 2, which is nothing but 184. So we just get an answer of sum of 1 and 2, 4 and 5. On adding this, we get 418. We know that the fifth number is nothing but the sum of 5 numbers minus sum of 4 numbers. On subtracting, we get 77, which is in our option D. So the average of 5 positive numbers is, if the average of 5 positive numbers is 99, then the average of first two and the last two numbers are 117 and 92. Then the answer for our third number is 77. In this way, we can calculate the numbers. Yes, That's all. We just go through all the chapters which are involved in our IMS set. All the best students. Prepare well for your exams. Thank you.